Okay, so I'm going to go over some key ideas that I took from the reading. Again, if you struggled with the Cornell notes and finding key ideas, please use this as a reference for some quick tips on what to take away from the reading. Otherwise, you can check your Cornell notes to see that you have similar ideas written down in the question and answer format. So I wanted to go over inertia. I think this is something that is really kind of abstract to understand, but really inertia is just the object's resistance to changing its motion and tendency to keep doing whatever it's doing. So an object has inertia when there's until there's an unbalanced force applied on it. So if an object, I'm right next to me, I have a box of Cheez-Its, and my Cheez-Its is sitting on my table. It has inertia because there's a balanced force of it on the table, the box and the table pushing on each other, but it's not moving because there's not an unbalanced force. Nothing is making it push to the side, pull to the left, lift up until I want to eat them. So everything has inertia. It's just about providing it, and let's see this. Let me try to get this fancy feature. Until there's an unbalanced force to overcome an object's inertia to make the object go faster, slower, or change direction. So yeah, an object has inertia until there's an unbalanced force, until there's a force that's overpowering its inertia before overpowering its piece, whether that is a balanced force of it sitting on a table, or a balanced force of two forces equally meeting each other at the same amount of strength in the opposite direction, until one force becomes greater and it becomes an unbalanced force to make an object change directions or change motion. Another point I want to go over is friction. Everything has friction. We'll look into friction a little bit more, but we haven't really looked at it until today. And it is a force that is caused by contact between two objects. This is an important force in Newton's third law. Inertia is important in Newton's first law. Friction is important in Newton's third law. It is the opposite of the direction of motion that the object is going. So if I'm walking, I'm always going to have friction in the opposite direction of my movement. But we'll go into that in specificity later on. Here's a good one to focus in on, Newton's second law. To equally change the motion of two objects of different mass, more force must be applied to the more massive object. So again, we can have more massive objects go the same acceleration as a less massive object. We just have to apply more force to it. And we saw that with the cart. When we increased the mass of the object, we increased the gravitational pull on that object, which increased the force on the cart and increase the acceleration. So this is really going to focus in on Newton's, let's see if I can do that, Newton's three laws. The first law of focusing on inertia and the on object wanting to remain at rest or in motion if no unbalanced force is acting on it. Newton's second law, which is just that we need greater force to move things of greater mass so that they can move at a greater acceleration. And that gives us the calculation, the equation, force equals mass times acceleration. And lastly, Newton's third law, which we've looked at in the last two lessons. This is looking at the fact that if there are two objects interacting, they will always have an opposite and equal force on each other, an equal magnitude of force in the opposite direction. And what's important about Newton's third law is that I lost my train of thought. So I'll come back to you guys because this video is about to end on me.